In this video, I'll be teaching you guys about nested quantifiers, and these right here are a couple examples of the nested quantifiers that I'm going to be covering in this video. Now, of course, I'm not only going to show you these, I'm going to swap the quantifiers locations around, maybe change some of the quantifiers to mix up their interpretations, and that is very important to understand because the order in which you place these quantifiers actually changes the logical statement, and I'll show you that in this video today. Let's take a look at this nested quantified statement first, and let's write the domain for x and y because you won't know what domain I'm talking about, right? There's no context of the problem without the domain. So let's say the domain for x and y is all real numbers. If you don't know what the symbol means, it just think of it as x and y is a set of all real numbers, right? So we're actually comparing x and y here, and we have two quantifiers, and we have two different variables. How do we interpret this in English? Well, let's say this. There exists, right, because that's what this little backwards E quantifier stands for. So there exists x, and there exists a y such that x is greater than y. Now, here's the thing about the statement. Try to interpret this. Oh, exists. So, after taking a good read on this, think about it. What does that mean? Well, that means that our statement, this quantified statement right here, is basically saying that for one value of x, there is one value of y that is less than x. Soak that in. Soak it in. All right, so we're saying one value of x, for one value of x, there exists one value of y where y is greater than x. Is this true? Is this not? Well, yeah, right? If we pick any x value, so x can be any value for these. Let's choose one, right? Example 3. And we could choose a value of y, right? Out of all real numbers, that is less than x, right? So that means this statement right here is true, okay? So there exists x and there exists a y such that x is greater than y. And that's true, and I gave you an example here, right? Now, what if we switched up the order of the quantifiers? Well, if we switched up the order of the quantifiers for this, or let's say we switch up the order of the variables for this, it wouldn't make much of a difference, right? You're basically saying the same thing, but you just changed the variable, right? So the sentence would be now there exists a y and there exists a x such that x is greater than y. Not really much of a difference, right? Basically the same thing, but instead you pick the y value first, right? So you pick the y value first. Let's say y is equal to 1. And then you could pick any x value, just one x value that is greater than y. And let's say x is equal to 3 in this case, right? So there exists the y, and there exists an x such that x is greater than y. Now, the order might not really seem like that important to you right now. But here, let me actually show you why it's important. So what if we used x, and what if we used y here? So let's use the exists for x and for all for y. How does this change up our statement? Well, let's first write this in English. So we have a there exists quantifier, so let's write down there exists x such that for all, right, so the for all quantifier, y, x is greater than y. So what is this statement saying? This statement is basically saying that there is a real number, x, right, that's our domain. There's a real number x such that for every single y value, x is greater than y. Can this be possible? Can we pick a value of x that is greater than every single y value? Well, let's pick a very large x value to test this out. Let's pick 10,000, all right? 10,000 is a very large x value, but does this hold true for every real number? No, it doesn't, right? For all y, we could choose any y value we want. That just proves this. And y, can be even larger number, 10,001. Right? That's a larger number. How about we keep going up, right? We can keep going up and up and up and up. Right? Let's go 10 to the power of 100. I think this is a Google. This is called the Google, or like the number Google. You could do 10 to the power of 100 plus 1, right? So y could be 10 to the power of 100 plus 1. There's no value of x that you can pick that is a real number where x will be greater than y. Where x will be greater than all real numbers. All right, there's no value you can pick unless, I don't know. I'm gonna search this up. Hold up. So I actually asked Google if infinity was a real number, but it is not. So no, there's no value of x that we can pick that will be greater than every single y value. Okay. Now this definition can change actually depending on the domain. What if our domain for x and y was? What if our domain for x? Let's say our domain for x was all numbers greater than 0. And our domain for y was all numbers less than 10. Okay, this is kind of compressed, right? Well, x can be greater than 0. So let's pick a number that's greater than 0, 100, right? So there exists an x such that for all y, x is greater than y. And that's the case, right? Y has to be less than 10. And 100 will always be greater than any number less than 10. Okay, so in the case of this domain, this statement is true. In the case of the previous domain for all real numbers, there's not a single instance of a number that we can pick for x where y is always less than x. So hopefully you get that. And now that I've got your attention deep in the video, I usually like just talking about random things while I write things down. So let's talk about, I recently got a good bit of subscribers. I'm not gonna lie. I'm not expecting that. I'm literally just making videos for fun, and I have like 372 subscribers. I have like 260 videos, something like that, right now. Oh, maybe in the future, if one of you guys are watching this 3 years later, and I have like 1,000 videos, give me a one applaud. Right? Clap your hands just once. Okay? Thank you. And let's do this. Let's do for all x and exists y. So we actually switched the placement of the quantifiers this time. Let's write down the sentence. So let's write down for all x, right? There exists. So for all x, because we have the for all quantifier in front of the x, and we're writing there exists for y. There exists such that x is greater than y. All right, so let's take a look at this statement right here. We're basically saying for every single possible x value, so for every x value, there is a y value that we can pick that is less than that x value. So for every x value, for every x positive integer, our new domain, there exists a y value such that x is greater than y. So let's go ahead and pick any random x value, like 5, for example. All right. We can pick, there exists a y such that y is less than x, right? We could pick y is equal to 1, and 1 is a positive integer. Now here's the thing about this statement. What if we pick x is equal to 1, right? If x is equal to 1, is there a positive integer that makes y less than 1? No, the smallest number we can possibly pick is 1. So y can only be like 1 in this case. Right? That's the smallest possible number. But x is also the smallest possible number. So this statement right here is false. Right? So if we were to interpret this statement, it is false. Because for every x value, there doesn't necessarily exist a y value that is less than x. This is not the case for only when x is equal to 1. When x is equal to 2, when x is equal to 2, yeah, y is equal to, when x is equal to 2, we can say y is equal to 1, and y is less than 2. If x was any number other than 1, this would be true. But since there is a single value that disproves this, this entire thing is false. So a good way to understand nested quantifiers is to write it down in sentence form. But let's go ahead and actually interpret some English statements here. Let's take a look at this nested quantified statement right here. And before I go on, I just want to give a big shout out to the Demon Slayer movie, released in 2025. Oh my god, it is so good, bro. That Demon Slayer, I'm telling you, if you are watching this in the future, or if you're watching this in the past, okay, never mind, that makes no sense. If you're watching this in the future, oh my god, and you haven't watched Demon Slayer, bro, watch it. People say it's overhyped. I hate those people, okay? But it's a very good movie. Akaza's backstory is so sad. Hey, if you know what I'm talking about, you know, bro. Akaza's backstory, Upper Moon 3, and Demon Slayer. Oh my god, man. Dude, it was a masterpiece. The backstory is just so sad. I think everyone in that theater was crying. I had a kid that literally said 6-7 out loud because Akaza unalived 67 people. Bruh, come on. That's not the right time to say 6-7. And also, if you're watching this future, you definitely think I'm corny as hell for saying 6-7. You could think that all you want, but you're here watching my video about nested quantifier statements. But okay, I was not trying to throw a stray at you, or was I? But let's go ahead and take a look at this nested quantified statement right here. We start with for all x, so let's write down for all, and instead of writing down x, we can just write down the domain, because in the context of the domain, x is actually something. It's not a number, right? In the previous example, x was a number, but we can write down for all students, since x is the domain of all students. There exists, right? There exists quantifier in front of y, a class they like. Or you can write down for all students there exists at least one class that they like, right? That's another way to interpret the sentence. There's many ways you can write it down, but take a look at the sentence. We're basically saying every single student has one class that they like, right? That's what this quantifier or quantified statement says with the statement L of x here. So x, or the predicate, sorry, x likes the class y. Okay, that's what this. Maybe I should have said that earlier. Whatever. Hopefully you read that. Hopefully you read that at the beginning. But for all students, there exists a class. Why did I write classes? I need to go back to grammar. But there exists a class they like. Okay? Think about that. Now, there's really no sample here that you can interpret, so I can't really give you anything for this, but yeah, I'm just trying to interpret the statement here. For all students, there exists a class they like. Hopefully, all students like at least one class. If you don't like at least one class, man, you are suffering in school. You know what? Just do a trade. I'm not saying that throw shade, bro. Trades are so important. Like, I actually think like they're very, very important. You guys are critical to society. But I highly doubt a trade person will be watching a discrete math video. If you are, props to you. You know, learning is a lifelong journey. But let's go ahead and actually switch around this quantifier. Quantified statement. Let's write down this right here. Right? So let's go ahead and interpret this as a sentence. There exists a student. Right? So there exists a student with this section here. And a class. Wait, let's not write like this. So there exists a student, and there exists a class such that a student likes that class. A student likes that class. Right? And we could have just simplified the sentence. This is just like the general format of how you should write quantified statements. There exists for all. I've just been using the general format. There's plenty of ways to write it, but I could have simplified this to there just exists a student that likes one class. Right? This is exactly what this is saying. I just wrote down there exists a student, and there exists a class such that a student likes that class. Right? One student likes one class. Right? There exists one student that likes one class. Let's take a look at this nested quantified statement right here, and we actually have two predicates. The predicate x, stands for that x is a student, and the domain for x is all people. So we need to make sure that we're talking about a student in this case. And we also have the predicate txy, which means that the person x took the class y, and the domain for y is all classes. So let's take a look at this one real quick. So we have this there exists, and we have this for all. So we have a there exists a person, and we have for all classes. Okay. Now here's the thing about this. If I use the standard form I've been using throughout this entire video, or that I guess it's a format that I chose to use off of ChatGPT telling me, but if I use that, then the sentence will be too wordy. So let's go ahead and interpret this without using that standard format, and I'll actually show you how to interpret this step by step. So we have a there exists. So there exists a person, but we can also just make this there is a person, right? That's a pretty simple way to say this. So there is a person that is a student, okay? That is a student, because one of the main things inside of our compound predicate right here is student, right? That person has to be a student. So there is a person that is a student, right? That T, right? That student took all classes, right? Because we have the for all quantifier right here. So there is a person that is a student that took all classes. And if we wanted to include the and, we could just say there's a person that is a student and that person took all classes. And that person took all classes. And you can kind of see how the sentence ties into this quantified statement, right? And this one was a little bit tricky because we actually have multiple predicates now. And you're going to get a lot of these in your discrete math class. In this example, I just switched around the quantifiers a little bit, and I also changed the condition to a conditional. The operator to a conditional, because if I use the and operator, this statement would not make sense at all. But let's actually interpret this real quick. So we have a for all quantifier attached to x. So x is all people. So let's write down for all people, right? This is kind of the gist of our sentence here. And we also have exists y, or exists a class. Okay? And the reason why I'm writing this and I'm not writing down the sentence is because this is the information that we got from the quantifiers for now. So let's keep this information written down or in the back of our minds. And now let's take a look at the predicates. So our predicate basically states that these people have to be students. They have to be students, okay? So that's the condition in order for this to apply. So the condition is that these people have to be students. So our sentence kind of looks like for all students, right? Or just all students. So we don't even have to write down all. We don't have to write down for. We can write down all students, right? So you have all students dash, and that's a condition. So the condition is the student. Now this right here is the conclusion. The conclusion is that a student x, right? And keep in mind, x is the domain of all people. But since we limited the condition to just students with this conditional here, we can just refer to x as students from now on. So we have student took class y. All right, in this statement right here, student took class y. Here's the thing about class: we just have one class. So basically, what we're saying is all students took at least one class. So that's kind of what we're interpreting here. All right. Now, if that wasn't clear to you, I can go through this again. So our quantifier for people is for all. And for all is limited by the condition student. So we have the condition here, and this condition requires us to talk about a student when we're referring to people. So we can kind of replace x with student in the context of this problem. And we're basically saying that these students are tied to this statement right here. So if you are a student, then you have done this statement. So if you are a student, then that means you have taken a class. And here's the thing about this quantifier. This quantifier only cares about one case. It doesn't care about every case. It doesn't care about every class. You just want to know that the student took a class off of this quantifier. So the information that this thing is portraying, or at least conveying, is all students took at least one class. And you could actually make the sentence super compressed. If you had to use like some for all x, there exists y such that would be a very annoying sentence. That would get very cluttery. That would be very hard to understand. But as long as you get the underlying understanding of this, this would be this is not that bad actually. Now, what if we put the AND operator here? If we put the AND operator, well, if we put the AND operator, this statement would completely collapse. And the reason why is because we're basically saying that you have to be a student for this, right? So we're saying every person is a student, right? Every person is a student. And we just wanted a conditional, right? We just want students that took at least one class. If we put an AND here, we're basically saying with this quantifier right here, we're basically saying that every single person is a student, or else you're going to get a single false. Right? If a person is not a student, if all people is not a student, right? Then you're going to get a false, right? And remember, for quantified statements, for the for all, if you get one false value, the entire thing becomes false. So the AND operator just simply doesn't work because it will just give you a false, like basically every single time. No, in no scenario will all people be students. That's why you should use the conditional. And this conditional kind of restricts, in a sense, the domain. And that is really it for the video. I kind of feel like this video was lower quality. I don't know. I'm a little bit distracted right now. I've got a freak ton of homework, so I haven't been able to post as much. But yeah, sorry if this video is a little lower quality. My explanations were probably a little worse, and I feel as if I didn't pick a good problem set. But anyways, I hoped the video still helped you understand how to interpret nested quantifiers. But if you have any questions, put it down in the comment section. If you found this video helpful, consider subscribing and liking the video. I appreciate all of you.